right, I don't know where I left off in yesterday's video, but today we are working with the sum of a finite arithmetic sequence. And you will need to know this. This is actually one thing that I put on my SAT ACT cheat sheet. The sum of the numbers is the number of terms. So the N stands for the number of terms over 2 times the first term plus the last. So, well, I need a pen. Number of terms, first term, last term. Now let's just look at B right here. It says the sum of the integers from 1 to 35. And I want to talk about this good old mathematician that came up with this. So what they're asking us to do is we're taking 1 plus 2 plus 3 all the way to 35. Now, this old mathematician back in the day said, you know what, I can go ahead and I can double this by writing it backwards. And he noticed that when he wrote it backwards and added down, that all these numbers were the same. He got 36 and 36 and 36. And so that's where he came up with the formula. The number of terms, well, there were 35 terms here, over 2, because I had the second row. I made a second row, and I took the first plus the last. So when I actually calculate the number of terms from 1 to 35, yes, I could use a calculator, 1 plus 2 plus 3, but this is an easy formula that you'll remember. And when I actually take 35 divided by 2 times 36, my answer ends up to be 630. So this is one of those great things on my SAT ACT cheat sheet. It's really not a cheat sheet, but that I have. It's a study sheet. This is one thing that you just look on a Friday night before taking it, or that week, maybe apply a few before taking it on a Saturday. And this is one of those things you're just going to remember because we're going to do enough of these in class. So what about the sum of the integers from 1 to 57? Okay, how many integers do I have from 1 to 57? So the sum of the numbers is equal to n over 2, first plus last. I know I have 57, and if I add first and last, I get 58, and I could just calculate that, and when I calculate that, I get 1,653. Now, you know that it always gets switched up on us, so let's go ahead and talk about what happens if somebody switches it up and says 2 plus 4 plus 6 all the way to 14. Yeah, again, I could probably put this in on my calculator, 2 plus 4, or I can just use that same formula. How many terms do I have from, really it's 1 to 14, but we're only talking about the evens. Good, I only have 7 terms. So we're going to take 7 divided by 2, and I know first plus last is 2 plus 14, which is 16. So if I was to just do this in my head, I'd cancel this out, and the answer is 56. So that was our first weird example. Now, it wouldn't be as fun if we had to take every other, or the evens, all the way added to 100. That's not as fun. But I know that if I add up all my evens all the way to 100, I know my number of terms. So I'm going to use that same formula. The sum of the number is equal to, I only have 50 terms now, because I know that every other going to 100 is 50. First and last, I add them, I get 102. And when I reduce 25 times 102, my answer is going to be 2,550. Let's look at one more weird one. What if I have my numbers going up by 3? So now I'm going up by 3, so I need to find the sum of the numbers is equal to, well, how many terms do I have from, really it's 1 to 66 going up by 3s. So can I just take 66 divided by 3, and that's my number of terms? Yes, I have 22 terms divided by 2. And if I add the first and the last, 3 plus 66 is 69. And my answer is, good, 759. All right, I have two more things to go over. Okay, number 6 has the 50th partial sum. New concept, we haven't heard of the 50th partial sum, but what they're saying is I'm going to find the sum of all these numbers. Oops, I need my pencil again. I'm going to find the sum of all these numbers going all the way up to the 50th number. So remember, this is the first number, the second number, the third number, the fourth number. So the first thing I have to do is find out what this 50th number is. And I can find that out by using our original sequence. A sub 1 plus n minus 1 times the common difference. Well, a sub 1 is negative 6. I'm looking for the 50th number, so I'm going to put 50 minus 1. And I'm going to multiply that by the common difference. Well, to go from negative 6 to negative 2 to 2 to 6, how much am I going up by? Good, I'm going up by 4. So negative 6 plus 49 times 4. And when I calculate this all together, I know that that last term is, I'm calculating, sorry, 49 times 4 minus 6. Did y'all get 190? All right, so now that I have 190 as my 50th term, I'm going to use that sum of the numbers. So I'm combining my two examples that we've used, the arithmetic sequence formula and the sum of the numbers formula. So my formula is n over 2 times the first and the last. Well, it told us in the question that we have 50 partial sums, so we're adding all these together, these 50 numbers. My first number was negative 6. My last number was 190. So I'm going to take 190, I'm going to subtract 6 and multiply that through by 25. And it looks like I end up getting 4,600. All right, we're going to look at one more because this is a word problem. It says, determine the seating capacity of an auditorium with 30 rows of seats. So I know that right here I'm going to have 30 rows. If there are 20 seats in the first row. So the first row has 20 seats. So it sounds like this auditorium is getting larger, so it's actually going to look like this. The next row has 22 seats. And then 24 seats. So as you can see, it's going up by 2s. So the first thing I have to do is find out how many seats are here in row 30. So let's go ahead and use a sub n, but that n is going to be 30. A sub 30 is equal to, well, the first term's 20. I know I'm looking for the 30th row, and it's all going up by 2. So when I put this in my calculator, it looks like that 30th row has 78 seats. Is that what you guys got? 78 seats? Good. So from here, I can now use the sum of the numbers. So now I'm adding numbers from 20 to 78. So let's write this out because this is going to look funny. 20, 22, 24, all the way to 78. Now remember, we could flip those around. 76, 74, all the way to 20. So I know when I add these together, I get 98. So the sum of the numbers is equal to n over 2, first plus last. So I know the first plus the last is 98, but here's the hard part. How many seats do I have between 20 to 78? Well, I guess it's not that hard because they told us that we have 30 rows, right? 30 rows. So I know that there's 30 rows of seats, which means there's going to be 30 terms. So that's where I find some students getting a little stuck. So we just have to find out what 15 times 98 is. 15 times 98 is 1,470.